So for a given Kohen's self-organizing features map with the weight W that is given as zero point 0.3, zero point 0.2, zero point 0.1, zero point 0.8, zero point 0.4, and zero point 0.5, 0.6, 0.7, 0.9, and zero point 2. So here we use the square of Euclidean distance to find out the cluster units Yj closest to input vector zero point 0.2 and zero point 0.4 using a learning rate of zero point 0.2, that is alpha, and we find out the new weights for unit Yj. So let us start the problem. First, we draw the picture based on the input vectors. What are the input vectors that is given? X1 and X2, the value is zero point 0.2 and zero point 0.2. And we do the learning rate, that is alpha, that is zero point 0.2. And what is the weight vector W? So weight vector W is given by the first row, the weights are, in the first row the weights are zero point 0.3, zero point 0.2, zero point 0.1, zero point 0.8, zero point 0.4. And in the second row, that is 0.5, 0.6, 0.7, zero point 0.9, and 0.2. So here you considering two inputs, that is x1 and x2, and there are five outputs, that is y1, y2, y3, y4, and y5. So you connect y1 with single and individual y1, y2, y3, y4, and y5. Similarly, we join x2 with the y1, y2, y3, y4, and y5. So first we join the x1 and y1, that is given 0.3. In the next line, there is y1, that is x1, y2, that is 0.2. Then x1, y3, that is 0.1. Then x1, y4, that is 0.8. And x1, y5, that is 0.4. Again, for x2, that is x2, y1, that is 0.5. x2, y2, that is 0.6. Then x2, y3, that is 0.7. Then x2, y4, that is 0.9. And x2, y5, that is 0.2. So here you considering x1 and x2 two different inputs. Okay. So now we calculate the Euclidean distance. That the formula is dj, that is equals to summation of I1 to 2, because here you considering only two inputs, that's x1 and x2, so the value of I is 2. And then wij minus xi whole square. So what is the formula? That is summation of I1 to 2, wij minus xi whole square. So what is the value of I? We know that is value of I is 2. So first here calculate w1j minus x1 whole square plus w2j minus x2 whole square. This is the formula. And now what is the value of j? The j value is 1 to 5. Okay, because here we considering 5 patterns. So first we calculate d1. So when you calculate d1, then you replace 1 in place of j. Therefore w1 1. When we replace j as 1, then it is w11 minus x1 whole square plus w21 minus x2 whole square. We know the value of w11 from the given input matrix, that is 0.3 minus 0.2 whole square plus 0.5 minus 0.4 whole square. Actually here w11 is 0.3, w11 is 0.3, and w21 is 0.5. And we know x1, that is 0.2, and x2, that is 0.2. So x1 and x2 are fixed. The value of x1 is 0.2 and x2 is 0.2. Okay, then we calculate the result and the value will become 0.0. Again we calculate d2. So if we when we calculate the d2, then it is w12 and this is w2. So what is the value of w12? That is 0.2. And what is the value of w22? That is 0.6. And we know the value of x1 and x2. Then ultimately we got 0.04. Next d3. So when we calculate d3, then it will become w13 and this will become w23. The value of w13 is 0.1 and value of w23 is 0.7. And the result will become 0.2. And for d4, this will be w14 and this will be w24. The value of w14 is 0.8 and value of w24 is 0.9. And these are the fixed. The value of x1 is equal to 0.2 and value of x2 is 0.4. So the result will become 0.61. And for d5, this is w15 and this is w25. Therefore, the w15 value is become 0.4 and w24 value will become 0.2. So 0.4 minus 0.2 whole square plus 0.2 minus 0.4 whole square. So ultimately value will become 0.08. Okay. So we calculate w1, w2, w3, w4. That is d1, d2, d3, d4, and d5. So since d1 is equal to 0.02 is the minimum value. D1 is the minimum value out of the 5 values. The winner unit is j is equal to 1. Okay. So we now update the weights on the winner unit, that is j is equal to 1. The weight updation formula is given by wij new is equal to wij old plus alpha into xi minus wij old. This is the formula for calculating the updation of weight. That is wij new is equal to wij old plus alpha into xi minus wij old. So now substituting k is equal to 1, so it will become how much? I1 new is equal to I1 old plus alpha xi minus I1 old. So for I is equal to 1 to 2, so we calculate two values, that is W11 and W21. So what is W11 new? That is W11 old plus alpha x1 minus W11 old. W11 old is 0.3 and alpha is 0.2, x1 is 0.2 and W11 old is 0.3, so value will become 0.28. And for W21 new, that is W21 old plus alpha into x2 minus W21 old. So W21 old value will become, the value is 0.5, alpha is 0.2 and x2 is 0.4 and W21 old is 0.2. The value will become 0.48. So the updated matrix is given by, we only change the x1 units for both the rows. That is, this will become 0.28 and this will become 0.48 and all the other values are same in the matrix W. That is 0.2, 0.1, 0.8, 0.4 and this is 0.6, 0.7, 0.9 and 0.2. So for the first input vector, that is x1 and x2, the value will become 0.6 and 0.6 and alpha will become 0.1. The weight matrix is initialized as, so this will become 0.3. We know as per the values, this is 0.5 and these are all the rest values are same, that is 0.2, 0.1, 0.8, 0.4, 0.6, 0.7, 0.9 and 0.2. So now we find the winner unit using square of Euclidean distance. The formula we know, that is dj is equal to summation of I1 to wij minus xi whole square. Okay. Again we calculate the same values in the same way. We know here there are two inputs x1 and x2, so here I is equal to 2 and here we considering 5 values, that is j is equal to 1 to 5. So what is d1? That is w11 minus x1. What is w11? That is 0.3 and what is w21? That is 0.5 from the previous matrix. And we know the value of x1 and x2 is equal to 0.6 and 0.6. x1 is 0.6 and x2 also 0.6. So the value will become, the new value of d1 is equal to 0.1. Similarly for d2, that is w12 and this is w22. w12 means 0.2 and w22 means 0.6. And both the value is same. If for x1 and x2, the value will become 0.0. For d3, this is 13, w13 and this is w23. The value of w13 is equal to 0.1 and the value of w23 is equal to 0.7 and the result will become 0.26. And for d4, this is w14 and this is w24. So for w14 it is 0.8 and w24 this is 0.9 and the value will become 0.13. And for 5, d5, that is w15 and w25. So this is, the value of w15 is 0.4 and the value of w25 is 0.2. So ultimately the result will become 0.2. Now since d2 is 0.08 is minimum value, the winner weight is Z2 here. Okay. So we now update the weights on the winner unit, that is alpha is equal to 0.1 and the weight updation formula, that is wij new is equal to wij old plus alpha xi minus wij old. So here j is equal to 2 because here we only change the minimum value. The unit which has the minimum value, we only change that unit only. So here we change the j is equal to 2 values only, that is d2. Okay, in this scenario. So we substituting j is equal to 2 in the equation above and we obtain, that is wi2 new is equal to wi2 old plus alpha xi minus wi2 old. Actually here I, there are two values 1 and 2. Again we set the formula, that is w12 new and w22 new. So what is the w12 new? That is w12 old plus alpha into x1 minus w12 old. So what is the w12 old? The value will become 0.2 and alpha is 0.1 given, and x1 is zero point 0.6, and what is the value of W12 old? That is 1. The value will become what? 0.24. Okay. And what is the value of W22 new? That is W22 old plus alpha into x2 minus W22 old. So what is the value of W22 old? That is zero point 0.6 plus alpha is 0.1 and x2 is zero point 0.6 and W22 old is zero point 0.6. So the value will become 0.6. Now the new weights or the new weight matrix is given by W. So here we change the x2 portion. So here these are the peaks, that is 0.5, 0.3 and zero point 0.5 as given. No changes there. Only change this inputs only. That is, it will become now 0.24 and this is zero point 0.6. And all the other base values are same. This is 0.1, 0.8, 0.4 and this is 0.7, 0.9 and 0 0.2. So this is the way, by using the Euclidean distance, we calculate the new weight matrix for any given input vectors.